Greetings and welcome to Week 2, Unit 5 on Program Outcomes PO9, PO10 and PO11. In the previous unit, we explored the nature of program outcomes PO6, PO7 and PO8. Now, in this unit, we try to understand the nature and importance of program outcomes PO9, PO10 and PO11 to a graduating engineer. Now, PO9 is related to communication. Let us read the statement as given by the NBA. Communicate effectively and inclusively within the engineering community and society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations considering cultural, language and learning differences. As you can see, it's a fairly tall order. There are several aspects of this. An engineer needs to communicate effectively with his own community. That means people who are similarly trained, they understand the same technical language, and sometimes they use so many acronyms only they will be able to understand. So he needs to communicate about his activities or whether what he is required to do with effectively with his own community. That's what everybody understands. But an engineer is also required to communicate with lay educated persons, including customers of one's own organization and society at large. What happens whenever you are a part of an organization has certain customers for which you are providing services or products. So to that extent, you have to constantly communicate, or you require to understand the needs of the customers, but they do not speak the same language, same technical language as you do. So to that extent, one needs to, you cannot insist on speaking only in your own language. You have to communicate with the customers in a language they will be able to appreciate. So you need to understand their way of speaking, and you have to modify your way of presentation for them to understand. And on top of that, sometimes you have to explain your activities to society at large. Let's say somebody is working in the area of battery management for electric vehicles. Now, you expect everyone to use electric vehicles, whether it is at a two-wheeler level or a three-wheeler level or a four-wheeler level. And what is it that they need to understand about battery management, or whatever issues the end user has, you have to understand that. So you have to evolve a language in which you can communicate. Both the requirements, communicating with customers, communicating with society at large, both are important. So a graduating engineer should have this ability. And on top of that, all engineers work in groups. There is hardly any activity where one person works on one project. Okay. And this requires all members to document and present their day-to-day work in a commonly agreed formats. You cannot insist on presenting your activity in your own format. If there is a group, sometimes the group can be maybe 3 to 4 or maybe 10, sometimes it can go even to hundreds. So in all such cases, one has to communicate with others in a commonly agreed format. Generally, this format will be decided by the organization or by the head of the project group, and everybody will have to report accordingly. And these days, this communication takes place online. You don't have to personally meet, you have to periodic, at whatever periodicity you have to communicate your activity at what stage yours is, and it will be summarized and the project leader will keep tracking of that. So this is an area, or this is a method of working that every a newcomer into an organization will have to get used to. Now that is one part. So what are the activities through which you can practice or get trained in this area of communication? Write technical documents or reports that get evaluated as per declared rubrics. When you write a report, uh, it has to follow certain, not only format, certain elements, and that is best defined by the rubrics. And when the rubrics are well defined, the teacher is able to communicate to the students how they should write the report. You cannot say write a report on certain technical activity and then judge whether it is good or bad, because they won't know on what basis you are evaluating the report. So the best way of presenting to them is through a set of rubrics, and the student is expected to follow those, operate within those rubrics, or to meet, perform as per those rubrics. He can also make short presentations to peers and lay persons that get evaluated as per declared rubrics. This is one activity. Yes, it takes effort and also resources to plan for this. But if every student is trained to make presentations to peers and lay persons that get evaluated as per declared rubrics. On one short topic, the students can be asked to prepare make a presentation to peers, that the language in which they both of you understand. Whereas you can also convert that into a presentation for lay persons who are not familiar with all the technicalities of your particular work. You can also train students in giving a proper feedback on a presented activity. Because giving feedback, a constructive feedback, is also an art, and you have to learn that. And sometimes you are shown a report and you have to document your feedback on a presented activity. See, one thing, verbally saying something during a presentation and giving it as feedback is one thing, but formally writing on a piece of paper and communicating is something else. And of course, not on a piece of paper these days. You can present it electronically. You can use your cell phone and give your input. And encourage and support group members in meeting the goals, because it is a group that has to achieve certain targets. Not all people will have exactly the same understanding or exactly the same abilities, same background. To that extent, uh, everybody will have to help one another to achieve the goals of a group. So, how do you do that? Yes, there are programs, there are people who can counsel on that, and somehow the student during the 4 years should undergo that kind of training to achieve that. Some people have a natural tendency to do that, some people require additional inputs. Now, some sample activities that what we presented was generic type of activities. Sample activities, specific. Conduct workshops or demonstrations explaining electrical safety or renewable energy systems to local communities, emphasizing accessible language and cultural sensitivity. You can plan an activity in such a way that you go to a community and explain on one of these aspects. It can be at a school level or it could be a community level, but this requires a lot of coordination, planning something, arranging for transport, arranging for presentation and so on. But it is possible and it is viable. Deliver presentations on complex topics like power systems or control theory, learning to tailor the content for diverse audiences, including non-specialists. Write comprehensive design and construction documentation that are understandable to clients, contractors, and regulatory authorities from different cultural backgrounds. The way you prepare a document for a client is different for the way you prepare it for contractor or to the regulatory body. And also, if you are talking about your regulatory bodies situated elsewhere and they come from a different cultural background, then the way the documentation will have to be prepared is completely different. Participate in public consultations for infrastructure projects, developing skills to communicate technical details effectively and inclusively. An institution, what it can do, it can make a small team of people from different branches of engineering, and then if you are participating in some kind of, if you can organize in a public consultation type of thing, and then how do you as a group you will communicate with that. It will be an interesting exercise, and generally the students will be enthusiastic if you can organize it properly. Develop user-friendly manuals and documentation for software or hardware products, considering language and cultural diversity in the audience. Preparing a user manual is a completely different proposition rather than creating a design documentation. Okay. Participate in outreach activities, explaining aerospace technology to schools or community groups, emphasizing accessible language and visual aids. These are some sample activities. Okay, communication is a completely different activity, and unless you focus on that, for some it may come a bit naturally, but the majority of us will have to constantly work at it and improve upon it. And it's a kind of a lifetime activity. It is not as if you have mastered at one place and that's it, you have become a great communicator. You have to continuously learn until the end of your life. Okay, you can learn and you can constantly learn by observing others and as the context keeps changing. And in fact, we used to take a position, you have not completed your technical activity, whatever bit, until you document it. Somehow documentation is seen by majority of the engineers as a maybe a necessary evil after the complete work is done. The work is completed and then you are writing a report on that. And so if the work is completed mentally, you are not prepared for you don't want to put that much effort to kind of write what you have done. It is not really that. Until you write the report, your work is not completed. Because once you start writing, you will find there will be plenty of small issues all over the place that you need to take care of, because once you start writing, you will have doubt. Can I write like this? That means your work is not actually complete. So until you document, your work is not completed in engineering. Please take that. If you believe in that, then you will become a much better engineer. And in fact, one of the traits that any organization uh, at the time of employment, they will always say, what is your ability to document or communicate? That is one of the highest priorities they have. Are you a good team member? Can you communicate? These two characteristics are very important, and unfortunately, the engineering programs are not that well designed to address this particular issue. Now, PO10 is related to project management and finance. Earlier, in engineering programs, there used to be some kind of management courses or project-based courses and so on, but somehow they kept on getting kind of pushed out, and project management is not officially taught in majority of the programs. Now, what is project management and finance as formally defined here? Apply knowledge and understanding of engineering management principles and economic decision making, and apply these to one's own work as a member and leader in a team, and to manage projects in multidisciplinary environments. There are lots of elements in this. Let us take a look at that. First thing you have to realize that most of the engineering activities are conducted in a project mode. Right? If you want to develop a software product, if you want to construct a building, anything is a project. What is a project? A project has certain timelines. That is, something has to be completed in a given time. Then the other one is it has limited financial and human resources available. Within these constraints, you have to complete the task. And that is the experience the program has to give to graduating engineers, that how to operate within a project. Yes, we do a project at the end of fourth year, but there is no particular, the goal is defined, you just perform some activity and then you get evaluated. That is not outcome based education. You have to define the goal in advance, that this is what you wish to achieve, and you have to demonstrate that you have achieved that particular goal in the given time. And generally, the projects are multidisciplinary in nature. It is not purely electrical, purely mechanical, or purely electronic. There will be, any project is most of the times will be multidisciplinary. And as we said, projects have limited financial sources and specified timelines. That is the most important. And you have plenty of tools available. There are plenty of literature available. There are standard textbooks available, where I think one can actually implement through a course project management and finance by the title, or project management and accounting. Some courses like that are available, and I think finally it should be brought into the regular curricular framework. And there is another issue. There is a certification that is available, like you have a Microsoft certification, and there are several such in the area of software and maintenance. You have certification programs. Here there is a certification program like PMI, Project Management Institute. It will keep conducting throughout the year some kind of a program, and they do have complete material. One can register for that and write the exam and get certified for it. If you get PMI certification, your employment possibilities in certain type of organization becomes very, very easy. And why is it so? Some of the organizations, for them to get contracts from international and national bodies, you have to show them how many engineers do you have with PMI or similar certification. Only such, if you have adequate number of such engineers, then you get that contract. So some organizations will value very much the PMI certification. It is better to do it during your final year, or immediately after your graduation one should seek the PMI certification for a good placement. So the requirements of this particular PO10 can be addressed through a course on engineering management and or project management. You have courses on both. It can also be addressed through well orchestrated mini and main projects. The rubrics of evaluation should reflect the student understanding of project management and estimation of cost. This is another unfortunate thing with most of the engineering programs in India. There is a cost associated with any activity, but somehow we focus on only on scientific and technical part of the activity rather than that what is the cost associated with that. Without cost, there is no engineering activity. That sensitivity to the cost. Finally, if you are producing a solution, what is it going to cost? It is not as if you have unlimited financial resources to do anything. We understand it at house level. After all, every house operates under some financial constraint. Within that, you have to operate. The same thing is valid for engineering projects, but our programs do not talk anything about the cost at all. So, estimation of cost, that experience will have to be given in at least one or two courses to sensitize the graduates regarding, as you see, the title of PO10 itself, Project Management and Finance. We can actually offer a course on what do you call? We called it in. We called it money. If you are interested, one can offer a course like that, or economic citizenship. It is all possible to do so. Okay, what are some of the sample activities that we can have from different branches of engineering? Lead or be part of a team to design a mechanical product, example a drone, HVAC system, applying project planning tools like Gantt charts, managing resources and making cost-effective engineering decisions. There are excellent tools available for project management, and the students can be exposed to do that. Develop and present economic analysis for integrating and renewable resources into existing grids, balancing technical feasibility with cost and management considerations. Manage or participate in projects like designing a microgrid, applying project management principles, and making resource allocation decisions in multidisciplinary teams. Some more, assess the economic and environmental impacts of alternative infrastructure solutions, presenting recommendations based on management and financial principles. Conduct economic justification for a new plant design, considering investment costs, operational expenses, and market factors. Everything need not be very big. It can be even a small. In a community, if you try to uh, prepare something, create a particular infrastructure, how do you go about doing it? It can be given in any institution, whether it is rurally located engineering college or in a mega city like Bangalore where you create you can talk about such projects or such activities in all programs, in all engineering programs. Manage the development of a software product or system applying project management tools like Agile or Scrum and estimating costs and timelines. Okay, come to the final one, PO11, lifelong learning. We don't have to justify that the things continuously change, especially technology changes so very fast these days that by the time you come out of the college, what you have learned already would be somewhat outdated. So, to be employable, to be current, you have to continuously learn. So, you don't require any more justification than that. So, what does PO11 say? Recognize the need for and have the preparation and ability for independent and lifelong learning, adaptability to new emerging technologies, and critical thinking in the broadest context of technological change. And this is to be in alignment with what we call WK8, which is knowledge and attitude profile, WK8. We will spend more time on those things when we come to writing outcomes. Okay, it's called triple L, lifelong learning. Triple L is a concept of learning that enables us to deal with continuous change in the life and practice of an engineer. And it is more true in the case of a faculty member, because you are continuously you are preparing your students to operate in a continuously changing environment. Lifelong learning is a skill. Lifelong learning skill is the ability to continue one's own self-education beyond the end of formal schooling. Earlier, at least not these days, earlier people used to say, I'm done with my learning. Now I will kind of live life kind of thing. In fact, with formal schooling is actually the beginning of learning for life. In fact, it is turning out to be like that. The technological changes in the last 100 years should convince us all to recognize that learning is a continuous and lifelong pursuit. It is not possible to progress in one's career only with the knowledge and skill set acquired at the time of graduation. Now, how do we prepare students for that kind of attitude and the effort that they need to put in? If students are to be motivated and equipped to continue learning themselves, their formal education must go beyond presentation of predetermined content. A program has a predetermined content, and as teachers we are presenting that to the students, but simultaneously teachers should also train them to go beyond the determined content. Activities that promote lifelong learning, like helping students to understand their own learning process. We call that as metacognition. We will deal with it when we come to that part of taxonomy of learning. Facilitating students to take responsibility for their own learning. Creating an atmosphere that promotes confidence in students' ability to succeed. Helping students see learning by themselves as a personally relevant to their interests and goals. That means they have to be convinced that they need to spend effort on their own to keep learning something beyond the what do you call the content as prescribed by the curriculum. Activities that promote self-learning can be incorporated in several core courses. That is, you give a small assignment in which they prepare something either for a presentation or just a short report. But for them to make them do that, you have to define the rubrics. You have to develop the rubrics in such a way you promote whatever you have in mind as a teacher to facilitate the students to work in that way. Okay, if you think that this is the way what we mean by lifelong preparing my student for lifelong learning, your rubric should reflect that, and you communicate to the student in advance so that he will exactly prepare the report or make presentation accordingly. Projects of all kinds generally promote self-learning. but appropriate rubrics are necessary for measurement. By, by manipulating the rubrics, say this is how you need to perform, you are communicating to him, and you will be rewarded, or your grade is based on your performing according to these rubrics. Okay, and that's where rubrics matter. These rubrics will be unfortunately be taken in another associated course on assessment. Some of the activities: determine the knowledge, skills, attitudes needed at the beginning of a project, writing a report, or developing a product or a process. Develop strategies to acquire the required knowledge and skills. Even to work on a strategy, how do I acquire the necessary skills? That itself is a part of lifelong learning. Acquire the required knowledge and skills outside the classroom. Participate in professional development, professional society activities, and co-curricular and extracurricular activities. Again, some institutions have what do you call professional societies on the campus, and if people are able to participate in activities related to that, like maintaining a small department journal, which can be brought out once in a month or once in a semester, and people can contribute to that and can create such a even such a e-journal, it will be excellent way of preparing yourself for lifelong learning. Okay, so we looked at the PO9, PO10, and PO11, and again I need to caution that program outcomes, while officially everybody acknowledges they are necessary, they are not that much internalized. Unless the faculty completely internalize and consider uh, are convinced of their necessity and importance, you cannot transmit that back to the students. So my plea with the faculty who are likely to take this particular course, you have to convince yourself that these are critical things that all students need to acquire. And in the next week, we will explore the cognitive levels of revised Bloom's taxonomy of learning. Thank you very much for your attention.